All right. Hello, everyone. So my name is Benjamin. I'm an Android software craftsman at Novoda. So Novoda is an Android software consultancy. So we build Android apps for clients. We are based in London, Berlin, Liverpool, and Barcelona. I've been working at Novoda for more than 2 years now. And in my day-to-day job, I've been trying to push for bringing more and more concepts from the functional world into our Android development world. And it might seem like a strange thing, but there's actually a lot that we can do daily that can help our life as developers, and we're going to try and see why. So what is functional programming? So if you turn to our good friend Wikipedia, functional programming is a paradigm that treats computation as the evaluation of mathematical function and avoids changing state in multiple data. And that sounds like a whole lot complex thing in ideas, so why are we actually doing this? So the reason why we're trying to do this is because we want to write less code. We are building more and more complex apps, and as we are building more and more complex apps, we have to maintain bigger code bases, more complex code bases. So we want our code to be concise. We want it to be expressive. We want to be able to glance at something and understand what it is doing. Why is it there? And we want to write small units. So we want to be able to write small units that we can reuse, that we can move around, and we can test efficiently and easily. But the more important point is, maybe that's going to work, yes. We want to focus on what we're doing. We don't want to focus on how we're doing it. So who here in this room knows how to write or read music? A few hands. But even if you don't know, you probably all know what this is, right? This is a music sheet. This is the way musicians have been interacting with music for centuries. This is the way we express ourselves in the realm of music. We have a language that allows us to declare how high is the note, how softly we should play it. Are we going to go fast, slow? And all that is a really high-level language that explains what is the music, what is it sounding like, what is the melody. What we don't do is use this. This is how the sound is going to be carried to your ears. This is the sound frequency. This doesn't tell us how beautiful or how soft the music is. The music sheet does. And what we're trying to build in the computing world is the exact same thing. We want to be able to look at something and understand what is it trying to achieve, not how it's trying to achieve it. So let's have a look at the core concepts of functional programming, the ones you would see quite commonly if you look online. One core concept is immutability. Immutability means there is no immutable state. It's unchangeable. It's changeless. What that means is if you want to create a modification to a value, you have to create a new value. But wait a minute. This sounds a bit complicated, right? It doesn't sound really logical. Like in the real world, you don't create copies of everything all over the place. So why are we doing this? It comes from a fundamental difference between the real world and the computing world. And our brains are used to understand the real world, the one you can handle and you see on a daily basis. So in the real world, if I hold an apple in my hand and I take a bite into it and I give it to you, once I gave it to you, I don't hold that apple anymore. I can't do anything with it. As long as you hold something in your hand, it's not changing. It's going to stay the same forever. In the computing world, we deal with references. And if I give something to you, I can keep a reference to it. And I can change it. And all of a sudden, the apple that you hold in your hand starts seeing more and more and more bytes coming onto it. And that is freaking us out. That is really confusing. So to be able to deal with that, to be able to prevent that, we will actually create a new apple and give it a new one. And because that apple cannot be modified, you are guaranteed that you can keep a hold on that apple and it will never change. It is safe to cache. It is safe to keep a hold on things and expect it to never change. It is safe to do threading. There is no complexity as long as we keep that rule. And that is why we do this little trick of creating new values every single time we change something. All right, the second concept is pure functions. A pure function is a function that, given the same input, will always give you the same output. It is also a function that has no side effect. So what is a side effect? A side effect is when a function kind of changes the world around itself. It has some form of impact in the world, in a program around it, that you cannot see from just executing it. You don't have a clear vision onto it. So the reason we're trying to do this is to be predictable. What we're trying to achieve is called referential transparency. And it's kind of a big word, but it means one thing. It means if I can replace a function call by its result, and it's not changing your program, then I've achieved referential transparency. And a good example of a function that is not pure is getAccount on the account management on Android. And I don't know if you've played with this, but it has the nice property of if you call it with the same input, it will probably always give you the same output, which is the account for that user. But if the account is already on the device, it will just give you the result. But if the account is not on a device, it will throw in a new activity, allow the user to log in, and then come back and give you the result. This is not predictable. When we execute that function, we don't know what's going to happen. I'm going to stay here, or am I going to go into a new activity? So we want to be able to know what the hell is happening. We want to be able to be predictable in our code, and that's why we want to aim towards pure function. All right, another key component, this one might be arguable, but I strongly believe that a good functional language and a good functional approach should be typed. Types are not a requirement, but they will help you a lot. They will help you model your domain. You are building a language that represents what you are building, the application you're building, your client's domain. What are you actually manipulating? It will help you to model also the absence of data. We have in Java a pretty common way of dealing with the absence of data, and it's using a null reference. And this is what's happening when we use it. All right, so you might know this famous quote about the billion-dollar mistake. Trying to model the absence of data is not a mistake. It's something that we need. The mistake here was just taking a shortcut that allows us to just hide the fact that the data is not there by having something pointing to nothing. So how can we model absence of data? What can we do to try and prevent the null pointer exception? So we have several patterns. You might have heard of the null object pattern, which is replacing the absence of data by an actual object that can do things. But this is only really useful in some scenarios. It is only really useful if the rest of the code doesn't have to worry if this is a null object or not. So take the example of an e tag, for example. It's this value that you can send back to your server to know if the data has changed or not. If you don't have it yet, you could initialize it with an empty string, for example. And that's fine. The rest of your code will just send it through, it'll get its response back, and everything works as expected. But for example, is it useful to use a null object for a username? Maybe not, because then you end up with those like isValid method all over the place. And what you've done, you remove the crash from the null pointer exception, but you introduced unexpected behavior. If someone doesn't check if the object is valid or not before using it, it will lead to unexpected behavior. And this is as bad as a null exception. It is something that is hidden. It's an implicit contract that you have to call this isValid method before using that object. And it's not really clear when I come into the project. I don't know if I need to do this or not. So a null object is really useful in a case when we have sensible defaults. So what do we do when we don't? Well, maybe we use an optional. So optional is a concept that allows us to use the type system to either express through the typing system directly or through maybe a wrapping class to tell to the user of that class, this might be there or might not be. It's the same principle, to be fair, with the null. You do have to check before it, but the typing system tells you you have to. It tells explicitly to anyone using this class, this might not be there. You have to deal with it. Okay, but in some scenarios, you might not have sensible defaults, and you might not be okay with it not being there. it's actually mandatory. So what do you do in that case? Well, in that case, prevent your object from ever being created without the data. Don't allow that object to be created without it. Crash in a constructor. And in your code, that means that you will have to handle it before creating the object. Validate your data early. Find solutions. Maybe you can remove this from the data set you have. Maybe you should warn something through some form of logging mechanism. Model the absence of data. Model the fact that that data is not valid to you, and act upon it. If you do that validation early, once you consume your data, you either have a data that is there, and you know you can use it. It's either a sensible default or this valid data. Or it's an optional, and you know that you have to check for it. You are in total control of what's happening in your app. You have expected behavior all the time. All right, so you might be telling me, this is crazy, you know, it's all fun, but we're doing Android, right? Like, I have to use like Haskell to do that. Well, it's not true. You can use any language, really. Like, functional paradigms are what they are. They're just concepts. You can apply them anywhere. You can use Java, C++, Python, anything. Like, of course, some languages like Haskell will force you to do some pure functions. It will force you to do things certain ways. But that doesn't mean you can't do it in a pure way in Java. That doesn't mean you can't make data immutable in Java. You just have to enforce it yourself. All right, so we're dealing with Java 7 and lower, because that's kind of what we have to deal with on Android. So you can use RxJava. You can use AutoValue, which allow you to help creation of immutable classes. You can use Guava, if you are a bit careful about the method count. Or you can even use Kotlin. I'm guessing some of you have probably been to like the 2 previous talks we had on Kotlin in this conference. So Kotlin is a really nice language. It's really up and coming. It has a lot of really nice functionalities. And it is definitely useful, but you don't have to use this. Like, you could use anything. So I will use Kotlin for the demos in my slide, because I find it a nice, concise language to express what I'm going to try and carry. But keep in mind that everything I'm going to talk about, you could use any language you want. You can use any toolkit you want. It's just about how do you approach a problem. So if you haven't been to the Kotlin talks before, this is a quick walkthrough through the Kotlin syntax. The first one is a function that takes a string and returns a string. The second function is a function that takes 2 parameters. The first one is an int, and the second one is a function that takes an int, returns an int, and the whole function returns an int itself. And the last one is an example of a lambda declaration. So it's an anonymous function that takes in here 2 ints and sums them up. So this is as far as basically you need to know about Kotlin to follow through the rest of the talk. It's just going to be mainly focused on the basics of the paradigms and the concepts, not about Kotlin itself. All right, so let's get functional. Let's see what can we do in a more functional way and why it's helping. Can someone tell me what this does? It's not obvious straight away, because it's doing a lot right here. So what could we do in a more functional way? So we could write it like this. And you might not be familiar with Kotlin. You might not be familiar with some of the functional concepts it's using here. But there's already some keywords here that should help you. It's grouping some words, and it's returning a pair of a key and a count of something. So it's doing the exact same thing as the previous one. It's counting the occurrences of words in the list of words. So this is an example of why functional approaches might be more concise, might be more expressive than their imperative counterparts. So this is a more expressive piece of code. And you might have heard, you know, code should be self-explanatory, comments are bad, all that. Yeah, true. But code should be self-explanatory doesn't mean the method name should tell you everything. Because a method name is as bad as a comment. You change something in a method, and all of a sudden, the method name doesn't represent what the method is doing anymore. The method name is a contract between the function and the rest of the code outside that is using it. It's allowing you to understand what the method is doing when you read it from outside. If I'm reading a function, I should know what it's doing just by looking at the code itself. This is when we have control over our code, and we understand what's happening. So it's not just a method name. Make sure that the code is understandable. We want to keep things concise, small enough so that we can reason with it, and we can move them around and test them efficiently. All right, so we also want to write code that is extensible. So what if now I want to take my occurrences of lists of words in a list, and I want to get only the ones that occur at least 3 times. I want to sort them by occurrences, and I actually don't care about the count anymore. I just want the list of words. So this can be just built in on top of count occurrences. So count occurrences here is a previous method that we had, and I can build on top of it, extending its behavior by adding new functions. So this is why we do functional programming. We do it to be able to compose small components. So you're going to tell me, yeah, this is all nice, but what about real cases? What about like real-life usage? Well, it is real-life usage. It is the type of level you're going to do actually your processing in. So what's the difference? How do you go from what you're actually doing right now to understanding smaller components and smaller units? So you focus on the data. You focus on the objects you're manipulating. What are you manipulating? Is this article, product, users? It's going to be value objects that you can make immutable, and you just reason with them in an immutable way. And you're going to collect them in potentially lists or just return single items. You act upon collection of those data values. The second part of it is what is your processing? What are you trying to achieve? So you might be trying to fetch a certain list of users. You might be trying to calculate the total of a basket. All of those are operations, functions that work upon potentially lists or collections of those objects, or returning collections or single elements. So what we're trying to do is basically think like shell. If you use shell, if you've ever used like small snippets, you probably don't do this every single time you try to do something. You don't write like a script just to do this, and then like have a huge folder with all your little scripts that like do all those small things. Most of the time, you'll do something like this. This is functional programming. This is using small components that are dedicated to do one thing and do it well, and then combining them together. In here, you list a certain number of files. You're going to grab to search the one that contain M, and then you're going to sort them, and then only keep the 15 first. And the idea here is this is what you're trying to achieve with your processing, with your domain. You're going to try and reason with what are the small steps I'm trying to achieve. I'm going to break it down in those small steps and combine them together to create your big processing. And to do that in functional languages and functional frameworks or tool sets, you have a lot of collections that exist. You could also rewrite those collections of functions yourself. They're not that complex if you take them independently. So you have a huge collection of them, map, flat map, filter. I'm not going to go through all of them, but the idea is when you start looking at things in a functional way, you want to try and use all those little tools, all those little things that exist, and decompose your processing using those functions. And this is you trying to express the processing you're trying to do using smaller components, smaller units. I am going to filter a list to only keep the ones I'm interested in. I am going to collect them in a certain way and then pass that around. I'm not doing a huge operation at once. I'm going to split it in smaller units. All right, so let's have a look. If I want to display only the saved articles, if I want to fetch the items in a basket that require some form of check, all of those are filtering logic. They're a list and a filter. If I want to get the total of a basket, if I want to find an item in the list, all of those are some form of traversal upon a collection, and they can be expressed using fold. But what is fold? So you might have heard the term fold before. You might have heard the term reduce, as in map reduce. Fold is a really powerful concept that is at the core of functional approaches to solve problems. It is composed of applying a function to each element upon a collection. So you have a function that takes 2 elements. One is the current element of the list you're at, and the second one is called an accumulator. The reason it's called an accumulator is because it is going to accumulate the state over that list. So you're going to apply the function to the first one, take the result of your function, and the result of that function will be the next value of the accumulator for the next pass through. So let's have a look. I have a collection of squirrels, and I'm trying to find the nicest one. So I will initialize my accumulator to a really ugly one. That way, I have a good initial state. And then I apply my function. I have 2 squirrels. What's the nicest one? I keep it. Then I apply to the second item in my list. And I output my result, and then I do it again. And at the end, I have found the nicest squirrel in my list. And what is really important here is the only thing I've defined is if you give me 2 squirrels, I can tell you which one is the nicest. And with that, applying fold with that function, you go through the whole list and you extract the nicest one. All right, let's take a more concrete example because, let's be frank, squirrels are a bit weird. So I have a basket. It's a collection of items, and an item has a barcode and a price. And I want to find the total of my basket. So I can do it like this. This is my traditional imperative approach. You initialize a variable to 0, you iterate to all the items in the basket, sum the price to that total, and return the total at the end. It's not difficult. It's quite simple, actually. But I can still write it differently. I can write it using fold, and it would look like this. I take the list of items, I fold upon them, starting at 0 and passing a function that, given the total in an item, give me back the results. I can even extract the function and call it sum. But then you're going to tell me, yeah, but I could extract functions. I can refactor, object-oriented code or like imperative code to make it look nicer. Yes, but then if you try and refactor your imperative code, what you're going to get is this. You have sum, takes an item and a total and return it. Doesn't look that much better though, does it? It's still the same for loop. You still have the total outside. The reason is, in the imperative approach, you have to have that state. That state has to stay somewhere. That total is the one you accumulate things into. It lives outside of that for loop. And because of that, you cannot refactor this better. You're stuck with that loop. You have to look at the fact that you're iterating to all those items and you're storing in that object over there. This is the how. This is not what you're trying to achieve. Whereas in a functional approach, you've taken completely the how out of the equation. You can focus on the function that just sums things up, and that's the only thing you need to care about. This is the power of functional refactoring. You can go the next step. You can take the boilerplate code of having to iterate through something or having to process a collection out of the equation. You rely on the fact that it's done once, it's done well, it's tested, and then you just focus on what you're trying to achieve. You write your small functions. And here, sum, it's part of my domain now. I test it. I know it works well. And that is one more little brick in your collection of functions. This is what we're trying to achieve. We're trying to create a world where we can abstract ourselves away from all those little details about iterating and transforming collections and just focusing on what we're trying to really achieve. I am going through a list and summing things up. That's what I want to do. All right, so you might be saying, oh, I want to do this tomorrow. This is amazing. You might also be saying, I'm completely lost and this is a lot to take. And it's fine. It's not something you're going to do like just tomorrow. Like, you're not going to jump in and say, oh, I have the revelation. Now I can do everything. It's something that takes time. As everything you're learning in your day-to-day job, you keep learning every day and you keep practicing. So start small. Tomorrow, you can already start by making some of your data immutable. It's an easy step to take. And it's something that will truly change the way you reason with code. And it will really help you and your coworkers to reason with your code. Aim for pure functions. So yes, we are doing applications that have to deal with network, database, sensors, touchscreens, interaction. Those things are side effect. But it's not the only thing you're doing. So if you have to write tomorrow something that will somehow filter and transform some data before saving it to the database, maybe try and split it into separate concerns. Have the persistence into database on its own world, and have the filtering and have the transformation being separate concerns that are pure functions. You'll be able to test them better, understand them better, and it will make your life easier. Validate your data really early. Make sure you model the absence of data. Don't allow nulls to creep in everywhere just because it's easier. It will not be in the long term. So try and make sure that data is predictable and validated, and all of a sudden you'll actually find bugs way earlier. You'll find small and nitty-gritty things that when you write your UI, you wouldn't think about, but you will realize just because the data tells you, wait a minute, this might not be there. And then, oh, I have to take that into account. So validate your data, express the absence of data as part of your domain. And keep in mind, focus on what you're trying to achieve, not how you're trying to achieve it. And I know that this might be a bit overwhelming because it's easy to get carried away in, I'm doing this is amazing, I'm writing my small piece of code. But what you're trying to do is not iterate through a list. You're trying to find something for your user. You are trying to extract some form of information out of it. It's focusing on what value you're trying to get out of it, what transformation in your domain, in your types you're trying to do. And if you try and keep that in mind every single time you kind of go back into the zone of like, oh, I'm going to do this, I'm going to do this, take a step back. Look at what you're trying to achieve. And it might actually help you solve quite tough problems that you might have been lost into otherwise. Keep learning. As I mentioned, it's not something you're going to do from one day to the next. It's a progressive learning experience. So learn a functional language. For me, it was Haskell. And it truly helped me to change my way of thinking, to force me to approach problems in a different way. It's not going to be something you're going to be using, in your day job tomorrow, but learning a functional language will truly help you to grasp different approaches to problems, to force you to think differently and see how multiple approaches can exist to a problem. Spend some time on pet projects. It's not easy to learn in a high-stress environment when you have to be productive or you have to know that you can deliver this in a given time frame. So don't do it on a high-stress environment. Just pick something you enjoy doing, pick a small project, and just try and do it there. Have fun. It's really easy to learn something when you're enjoying what you're doing. When you're having fun doing it, you can push yourself. You can go back to it every day and be, oh, what if I tried this way, or what if I tried this way? It's something you will enjoy doing and you'll actually remember much easier. And, time goes, time flies, you'll be more comfortable, you'll be dancing around. Really don't hesitate to have fun and embrace it. And within no time, you'll be comfortable. So dive in. I have a few good reads to recommend to you if you want to follow through. For anyone wanting to learn Haskell, Learn Your Haskell for Great Good is a great book. It's available for free online. You can also buy the ebook or buy it on Amazon. It's a really interesting book to kind of jump without any prior experience to Haskell or functional languages. It goes slowly through the different concepts and different bits and pieces and helps you have a better grasp of what Haskell is. Functional Programming in Java is also a really interesting book. If you don't feel like going into a completely foreign language, it was a book written to kind of introduce the concepts from Java 8. And it's really great at like kind of showcasing different new introductions to Java 8. And as I mentioned, it's not about the language version. It's not about the framework. Whatever you learn in that book, you can apply in Java 7. You can apply in any language. If you want to dive in a bit more, this is probably the most advanced of the list. It's called Category Theory for Programmers. It's not a full finished book yet. The author is actually publishing it as it's going through it on his blog. And it's kind of going on how we can use type and categories to solve some problems in our code. He's actually using C++ for some examples. So it's just to show the fact that language doesn't really matter. So yeah, have fun and keep in mind, focus on what you're trying to achieve, not how you're trying to achieve it. Thank you.
Thank you. What areas in your Android development and in your practice and in your own applications, what areas are you focusing on pulling functional programming techniques in?
So the area where I'm focusing most is my domain layer. So everything that deals with like the data processing. So I try and have hard validation of the data I'm manipulating, and then all the orchestration around fetching from API, saving into database, transforming this, saving it, passing it around. I'm trying to express this in the most functional way possible. In the UI bit, I kind of leave it to be close to the Android way of doing things because in the UI bit, we want to be efficient. We're probably going to have mutable states because, drawing passes and all that stuff. So the idea is, I think the place where you have the most benefit from it is what you're manipulating, your actual domain, which is the place where bugs are probably the most dangerous because it can completely transform the behavior of your app. No other question? Well, thank you very much.